Welcome, everybody. Welcome to our AI for Science workshop. We're going to be talking about prompt engineering and something that was previously called Code Interpreter, but is now called Advanced Data Analytics. We're going to be talking about the different ways that large language models with these capabilities can make a huge difference in your research. But first, I'm going to start with some questions. So if you would, unmute yourself. If you'd like to, you can just put it into the chat. But what I'm interested in is, first of all, what are some things that take a lot of time in your research? The tasks. What takes time in your research right now? And for those of you who don't know my trick, I have my tea here. When I have my tea up, that means I'm going to be very happy to wait for a moment for someone to answer. So my question to you is, what in your research takes a significant amount of time right now? Okay, so Julia, collecting data. Absolutely, that makes sense. What else? Processing proteomics and large data. So actually doing the processing, the data, reading and writing papers. Absolutely. Other things that take people a lot of time in their research? Figuring out just how to tweak figures to be just right. Absolutely, that can take a great deal of time. Iterating through different possibilities. Reading and writing papers and grants. Fantastic. Ooh, asking interesting questions. Absolutely. These are terrific. So I actually have some good news. So one of the most useful things that large language models can do for us is to augment us in our work. And what we're going to be talking about today is a way to use large language models that would augment you in your work and be able to help you with almost all of what you just mentioned here. The only one that I'm a little bit unsure about, depends on what you mean by collecting data, but pretty much everything else can be moved forward by the use of large language models. So what we're going to do is we're first going to talk about using large language models to wrangle data and to make this a repeatable process. Then we're going to be talking about using large language models to address sort of the higher level things, how to approach problems, how to think about papers, and how to start generating new types of ideas as well. So these are all the things that we're going to be discussing today. Although I gotta tell you, Charo, I'm kind of thinking of sort of flipping the script a little bit and starting with sort of the higher level thinking about things. What do you think? Just start with the papers?
Yeah, I think that makes sense.
Okay. Yeah, because let me share something with you. I had a conversation yesterday with someone, with Steven Tyler, who's a great astronomer that we have here. And he was mentioning an approach that they're using called normalizing flows. And it was something I wasn't as familiar with. But he was pointing out some things of how it handled complex distributions in such a way that you could explore distributions and actually come up with nice approximations for very complex things. And this is sort of in a Bayesian approach. But I didn't know it all that well. And I was wondering what it had to do with transformer models, because one way to think about transformer models is that they're learning complex distributions. But I just wasn't too sure how to think about it together. So what I did was I used a large language model called Claude. So I went to claude.ai. And one of the interesting things about Claude.ai, or the Claude model, it's called Claude v2, is that it has an immense context length. That means that you can load whole papers, whole chapters, and still have plenty of room to discuss these things. So this means that you can upload one paper or multiple papers, and be able to ask questions and theorize about the entire paper all at once. And the model is keeping track of everything which is in those papers, so you can very quickly and nimbly approach different ideas. So this is what this workflow looked like. So keep in mind, I had the meeting in the afternoon, and about an hour later, it was really on my mind, and I wanted to begin to explore these ideas. But did I have time to read, or did I even know whether reading the full normalizing flows paper was going to be worthwhile? I only had a couple of hours to try to start doing this, and I didn't know whether to invest my time there. So what did I do? I uploaded the normalizing flows paper, and this is here's that paper that I chose: Normalizing Flows, an Introduction and Review of Current Methods. Okay. Then the other thing that I did was I uploaded a paper I very much like, Formal Algorithms for Transformers, which is a beautiful high-level formal algorithmic approach to transformers. And what I did was I uploaded both of these to Claude. The first thing that Claude did was summarize the papers. So normalizing flows. Okay, these are generative models, allow efficient sampling and density estimation by transforming a simple base distribution through a series of invertible mappings. Okay, great. This may not make sense to you, but to me it was like, okay, now I got a clue about what's going on. Exact likelihood calculation and sampling by applying the change of variables formula. Interesting. That's meaningful to me. That helps me get a better understanding of what's happening without having to read the multi-page paper. Okay, various flow architectures, universal approximation. Boy, this sounds really interesting. I'm probably going to read this whole paper. And then transformers. Actually, transformers, I've read this a number of times. I teach it in my transformers class, which is open, by the way, to seniors and above. It's a graduate level class. Also love to have faculty and postdocs and staff. So if you're interested, I teach it every semester. If you're interested, let me know. Transformers, deep neural networks. Yes, yes, yes. It got this right. Attention computes representations. Yes. Really good summary. So, in summary, normalizing flows and transformers are powerful, deep generative models with very different architectures that have enabled breakthroughs across many domains. Cool beans. Let's start thinking about this. How might you augment a transformer to make use of normalizing flows? Complete shot in the dark. I'm like, what do they have to do with one another? How could you use one to improve the other? I have no idea whether this is going to be working. This is on the way, Juan, to asking interesting questions. This question is not necessarily an interesting question, but this might lead to an interesting question. And Katie, this actually directly, goes towards reading papers. I already have a good summary of it. Now I kind of know where I need to go and sort of spend more time. Richard, reading and writing papers. This gives me an overview of where I need to concentrate. So I don't have to read the whole thing. I can concentrate on what I want. Here are a few ideas for augmenting transformer with normalizing flows. Okay, replace the logit later with normalizing flow. Not a bad idea. Computationally, probably not a good idea, but interesting. One that I hadn't thought of. Add normalizing flows in the feed-forward layers. Okay, also kind of interesting. Now, this is interesting. Using normalizing flows for stochastic latent variables. I would not have thought of this. I don't know if it's a good idea, but now I'm thinking about how these two very different approaches might have something to do with one another. Now, what the model is doing is simply looking at the structures and the ideas and figuring out how they might fit together between the two papers. It's not necessarily a good idea, but it is a novel idea. And so now what I can do is I can start iterating, generate continuous representations. Okay, please take idea number 4 and represent that in the formal pseudocode described in the formal algorithms paper. I'm diving in. All right, so it goes in here, it gives me some formal algorithmic approach here, which is not bad. It helps me understand a little bit more. And then I can begin to dive in more. So this gives you an idea of how you can use the models to augment your very creative thinking about how very disparate ideas might go together, even if you need to upload many different papers, looking for the commonalities, looking for what hasn't been covered from one in the other, and begin to explore new ideas that you can bounce off of the large language model to explore. I'm going to pause here. What questions or comments do you have about this kind of an approach of the use of large language models?
So I had actually a question. Do you hear me?
Yes, I can. Please go ahead, Gregor.
So have you actually read these two papers in detail to actually verify how accurate this is?
The formal
What
algorithms,
spits?
yeah, the formal algorithms I've read like many times and taught it. I've since gone back and looked at the normalizing flows, and I'm pretty happy with the summarization. But boy, yeah, with the formal algorithms, it got it exactly right. So and here's the difference, Gregor, because I know where you're going. I think. Tell me. Hallucinations. How do we know to trust what the model is generating? That's the beauty of the long context, because when it is in the context, it is much less likely to simply hallucinate. If I tried this with GPT-4 and not been able to upload the models, I wouldn't trust it as far as I could throw it. But because this is a long context model and everything is in the context, I have much more confidence, and I've gotten good results because it's all in the single context length.
And the other question I had is there a limit of how many like papers, for example, you can upload here?
Yeah, it's this is not doing what's called RAG. So this is not uploading the papers and then pulling chunks in. Instead, this is trying to load it all into the context. Claude V2 has a context length of 100,000 tokens. That translates to about 75,000 words. So that's kind of your limit, you know. It has a formal limit of 5 megabytes per paper and up to 5 papers, or maybe 10 megabytes per paper. But depending, you can run out. So I've done like 4 or 5 papers at one time where I've, sort of put them all in to think about. Great questions. So did I answer your question though about that hallucination? Is that where you were going with it, whether to trust it?
Yes, I mean I can see the point you're making, because you basically just have these two papers where you're based on, and it doesn't use any context from the internet or
Exactly.
in terms of knowledge. It uses a context to learn how to analyze and phrase, or
exactly. If you depend on the models for what it knows what it's been trained on, it's like the fuzzy JPEG. This is not a good idea, not a good use. However, if you can fit things into the context, then you can trust it much more, because now it is all being immediately considered in generating its response.
Yeah, makes sense. Thanks.
Absolutely. One other thing I'll mention, because somebody mentioned grants as well. Katie, you mentioned grants. This is also a really good way to get a review of your grant. So go ahead and upload, the RFP. Go ahead and upload. Now, keep in mind, you're like sending this out. So if anything is proprietary, do not do this. But if you are going to be sharing out your grant, and if you're not concerned, then you can upload that and have it actually review your grant and how well you're meeting the requirements of the RFP, what questions the reviewers might have. Those are all things that you can do once you have long context. If you have sensitive information, and if you don't want to be uploading your stuff to Claude, there's a new generation of private models that you can run, that we're getting agreements to be able to do this at Vanderbilt. But even running locally, come and talk to us at the DSI. There are versions of Llama V2 which also have 100,000 context length. We don't know how good they are because we're still just starting to play with them, but we're going to be exploring that. All right. One other thing that I'll finish up with the long context is this is also a great way to just investigate a single paper. So here I've uploaded formal algorithms, and now what I want to do is I want to learn about the paper. I'm not just looking to sort of explore. So here I've uploaded the paper, and I had a question about a particular algorithm. So this paper has like 13 different algorithms. And so I was able to say, hey, in algorithm 5, what's the dimension of the Y matrix? And because it's all in context, it's able to go in and say, oh, algorithm 5 is multi-head attention. The dimension of Y is this. And the interesting thing is it had to sort of figure this out. It wasn't written exactly right there. And then it tells me what the different things are, explains what's going on. Here's the dimensionality. Here's how it came up with it. I can even do things like explain this algorithm, and it will describe what's going on. this type of being able to interact with your papers, especially the longer papers, having them all in context, is a very powerful thing. It helps me figure out how to explain in different ways to my students, because even though I might understand this in a way, I want to have an explanation from a different viewpoint. So this gives me a really good idea of how to explain to many different folks that have different backgrounds. Any final comments about using long context models to explore ideas, explore review grants, and develop new ideas? All right. Then let's go on to, let me make sure I haven't missed anything in chat. Terrific. Then let's go on to sort of a real bench use, right? So let's say that you have data. So you have some data that you want to analyze, and you might even want to build a model on. And again, this has to be data that you can share. But let's say that you have data which is publicly available that you can share. Let me show you something that you can do with OpenAI with chat. So this does require that you have Chat Plus. So I pay for Chat Plus $20 a month, the best $20 a month I have ever spent. Ever. Same thing with Claude. I pay for the professional version of Claude, which gives me more interactions with it. Also $20 a month. Absolutely. I don't care if I have to do without eating out. It's absolutely worth it. So once you do this, then you can choose GPT 3.5 or GPT 4. You want GPT 4. Then under settings, you want to make sure that you go to settings and you go to beta features. You want to make sure, oh, this is fascinating. Now we have browse with Bing again. That's nice. That you turn on advanced data analysis. This is this last one. This used to be called Code Interpreter, which was a terrible name. Now it's called Advanced Data Analysis, which is a more terrible name. OpenAI is good with a whole bunch of things, but I wish to God that they would actually use GPT-4 to help them name some of the capabilities of their offerings, because they're terrible names. Advanced Data Analytics empowers GPT-4 with what I think of as a meta tool. And we've had some workshops on this already. And there's a description that Jules White has used in some of our other workshops that I really like. It's a meta tool. So advanced data analytics will keep track of what's happening in your chat. And if you mention something that needs a tool, it will pull up a Python instance, write Python code to create the tool that you need to do the thing that you mentioned in the chat. So he describes this as like a magical shovel. So let's say you're shoveling the backyard. You want to get a hole, and you're shoveling, and you hit a huge rock that is not going to come out. You're going to have to break it up. The shovel realizes that you have a rock in front of you. It turns itself into a pickaxe, jumps out of your hand, hammers at that big rock until it's broken down, turns itself back into a shovel, and so you can continue shoveling. Sounds really weird, sounds really magical, but that's a meta tool. It turns itself into whatever you need in order to solve a problem. What on earth does it even mean? Let's try it. So I'm going to go to GPT-4. I'm going to turn on advanced data analytics right here. Notice that the first thing that happened was that a plus appeared. This means I can upload data. I can attach files. Warning, you're giving away your data. You're handing this off to OpenAI. If your data is sensitive at all, if it has FERPA, if it has anything sensitive or something you don't want to share, do not do this. If, however, this is publicly available data, have at it. I happen to have publicly available data. So here's the data that I have. I'm going to do a plus, and I'm going to go to my downloads, and I'm going to look for something that's called soil. So this is data from a really cool project that Marcus Eberl and his graduate students and teams from the Data Science Institute worked on together. And the idea is this, in brief. He has a particle analyzer. He's able to pour soil samples through it. And it takes 40 different types of measure, 42, 46, I've forgotten, many different measurements of each particle in the soil sample. And what he's interested in is the few number of particles that actually are the leavings from stone knapping. That's creating stone tools. So say you have a piece of rock, you're breaking off pieces of the rock by using another piece of stone to create sharp edges, to create maybe arrowheads or knives or whatever have you. Stone Age people, this is how they created stone tools. Well, when you do that, you leave behind small little pieces. They're called lithic microdebitage. And he has a pure sample of lithic microdebitage, and he has soil. And what we want to do is we want to explore what are the differences between lithic microdebitage, these small leavings, versus soil. And the idea here is see if you can train a classifier, right? So that you can just pour soil sample through and determine whether in ancient times people were creating tools where you took the soil sample. Amazing. This is microscopic archaeology is what it is. So I've uploaded this data, and I'm going to say, hey, please give me an overview of the data. All right, so to provide an overview of the data, I'll first unzip the uploaded files and examine its contents. Notice what it's doing right here. Say working. If you explore what this is doing, it's making a tool. It's making a tool first to unzip. Then when it unzips, it's actually going to be loading them up. It's going to list the files. It's going to unzip them. So great. So it contains 2 files, archaeological soil data and lithic experimental data. Would you like an overview of both files, or is there a specific file you're interested in? So the shovel saw that I needed to unzip. And so it created an unzip tool, and now it's asking me if I want to go further. Yes, both files, please. I'll start by loading the data from the CSV files and providing some basic summary statistics and visualizations. So, Ryan, you mentioned figuring out how to tweak figures to be just right. This is a step towards that, right? So what's happening in the background right now? It created code. It uses pandas. So it loaded up the data here, and then it did a head, and it seems the output was truncated, and there's some data type warning. So it's going through, it's going to be fixing it. Please keep all the columns, but use just a sampling of the rows. Do both files. So you can almost think of this as a very, well-trained assistant that knows how to write Python code. So now it's going through. So a couple of things here. One, I'll be able to continue my iteration all the way up through. I'm going to ask it to create some visualizations in just a moment as well. One thing to keep in mind is that even though it's writing code for me, it is going to go away. This is not reproducible. I'm going to have to save my work and explicitly ask it to save my work for me. And Dr. Bell is going to be talking a little bit more about this to make this reproducible. But here you can see it's sort of coming up with some data here. It has 48 columns, and it's sort of showing me what's in there. So it's actually pulling data in to show me what this looks like. And now I'm going to go and stop. I'm going to say, please create a visualization of the difference. And I'm going to, let's go and say, I'm going to say, first I'm going to say, please list all of the columns, the column headers and what you think they represent. So this is exploratory data analysis, where it's allowing me to very quickly explore. So ID, diameter along major axis. So it's giving me a good guess of what this might be. So these are for each individual particle. It's giving me these different types of measures. And I'm waiting for one in particular that might be important. So when you're creating stone tools, one of the things which is interesting is that the stone tools, the leadings from the stone tools are going to be very, very thin, very, very thin. I'm wondering if there isn't something like see-throughness or opacity, transparency. There we go. I'm wondering if transparency is different between the soil sample and the lithic microdebitage. So I'm going to go and ask this. Please give me a graph showing the difference in transparency between the two files. So now, again, it's creating the tool, taking 1,000 random samples, and later I'll probably say stop taking the samples and just do all of them. It's going to show the basic information first. So it says that they're both going to be the same. Both have transparency. Going to make sure that they're both numerical. So these are all the things that would take you time to actually read in, get it right, get it approximately right. You can always go back and modify this code. You can save this code. It'll save you immense amounts of time as you're wrangling your data. You can ask for the model. You can ask for this to reshape the data. You can do whatever you need to, and then you save the code, and then you can iterate on the code yourself. So you don't just have to leave it the way that it was doing it here. Here it's doing a histogram plot between the two, and then it's going to show the outcome. So let's see what it shows me. So it looks like the lithic microdebitage is more transparent than the archaeological soil sample. As a matter of fact, some of the soil, a good bit of it is just like has zero transparency whatsoever. So already I know that I'm off to the right start here. So I'm going to give away the rest of the story here. This project took a team of about 6 folks, data scientists and folks from Marcus Eberl's lab, an entire semester to get to the point where they could train a model. I'm not going to take the rest of the time to do this, but in my very first half hour with our brand new data scientists here who are starting our master's program here, in half an hour, I took them through everything that we did in that full semester work. And by the end of that half hour, we had a very good trained random forest model, which could reliably tell the difference between lithic microdebitage and soil. And yes, transparency was one of the most important factors there. But the speed up that we had, the acceleration that we had on that work was immense. From months of person hour work to really a matter of half an hour so we get to that first point. There were problems with its solution. We had to go through, and we'd probably have to spend another couple of weeks validating, going through, making sure that we'd gotten everything exactly right. But really getting to that first proof of concept, and yes, that you could tell the difference there, was immeasurably important and would allow us to accelerate the work that we had immensely. So imagine this with your data. Exploring your data, testing out initial theories, figuring out where you might want to go next. In order to make this reproducible, you'll want to keep in mind that you'll want to actually save this code. So, Dr. Bell, can I hand off to you now to talk about other types of uses for this and also how to make this reproducible?
Sure, that sounds great. So again, my name is Sharo Bell, and I am a senior data scientist at the DSI. I noticed that someone at the very beginning of the set of questions said that one of the challenges they face in their research is collecting data. And so I'm going to choose to believe that that means that it is hard to sometimes get people to enroll in your studies. It's hard to get people to respond to surveys. It's hard to get those survey answers to make sure that they're real responses and not spam responses. It's hard to think about the analysis or begin to perform the analysis that you would want to do without having some data to even think about approaching the question with. Well, this is actually one of my favorite uses of code interpreter, advanced data analytics. And it is the ability for this platform to be able to help us to generate these data sets that we can begin working with even before we have responses. Another component of this is, as Jesse was saying, careful about uploading your data to some other platform. A lot of the data that we have at Vanderbilt, we are right here next to the medical center. We have data on students. These are things that we do want to analyze, but we do not want to upload onto anyone else's servers, especially when thinking about IRB and privacy and laws. So a way that we can go about that is to generate this synthetic data set or this fake or demo data for us to be able to do some analyses on it, describe essentially the code or the framework or the steps that we want to do for our analyses, and use our synthetic data to actually have something to work with. So I'm going to show you some examples of that today. I have been just making so many data sets. I'll just have to pick which one is looking good. But let me start with this one. And this is also based on one of the projects that we did with Dr. Joe Webby and some of his students over in special education. And it is all about teacher data sets, labeling teacher data, and understanding the number of different types of statements made by teachers. So let me share my screen and we will jump right on in. All right. So what happened in this study was that there were a set of teachers, and I'm not sure how familiar you are with teacher observations, but generally what happens is as teachers teach, they are observed throughout the year through a number of observers, and often they are evaluated based on these observations. And with the quantitative approach that's taken, there are these different labels that the teachers get based on what they have said during class. And so the data collection proceeds by actually recording the teacher and student conversation during the class. And then the conversation is transcribed in such a way that the teacher is all that's left in the transcription and the students are kind of eliminated from that transcription. However, as we know, sometimes when we go to transcribe things, even though we have tried to anonymize to our very best degree of our capabilities, there's some name that appears that the teacher says, or there's some sort of identifying information that regardless of maybe how strongly we feel about this thing being anonymized, we still just don't want to take the chance that that thing could be uploaded and then shared and then recognized, especially with these models that are still training. And so what we could do instead, okay, what if we had an assistant, something that could generate the conversation between teacher and student, or just what an instructional conversation would look like during the class. Maybe we tell it what kind of class we want, and we tell it how much we want of the conversation to be. We want to tell it maybe what kind of day the teacher is having, and then we want to tell it exactly what we want our data set to look like to match what we would get from this teacher observation survey or from this study. So you can see exactly how I've chosen to generate such a thing using advanced data analysis. And so essentially what was in the data was a bunch of timestamps with lots of lovely NAs in there to help us out, because you know how NAs are always right there to help you when you want to do analyses. So we have these timestamps in a particular kind of format. This is going to match the format that is going to be created by the transcribers about the duration of the statements made by the teachers. Each of the statements made by the teachers are on different rows of this data frame or of this table. And then at the very end, we have this label column, and we're just representing all of the teacher statements with this label. So something nice about this is we want to create a data set like this one. This is also actually a synthetic data set. Something that you may notice about Code Interpreter is that whenever you go to use it, sometimes the functionality is better whenever you give it an example of what you want to see. So maybe 2 or 3 lines of what you actually want this data output to look like. So is that real data? No. Is it something that I just casually wrote in the right format? Yes, it is. And again, that sometimes really helps to get the tone of the conversation right, some of the missingness of the data right, and just to give it a good representation of actually what you're after. So here again, I just described the data set, gave it an example data set to help it along, and told it what I wanted to get out of this whole study. And so something also that you will notice about Code Interpreter, or sorry, so I'm going to say Code Interpreter so much, I'm so used to saying it, but it really is Advanced Data Analytics. Whichever one I say, do know that I am talking about Advanced Data Analytics. Same platform, different name, sort of. Okay, so something else that I like about this Advanced Data Analytics is that it has this very assistant-y functionality, and it has an aspect, a scientific aspect to it, where as scientists, as researchers, as people who study, we don't just like look at things and we're like, ah, that's right, and we just keep on going. We investigate what is going on, we explain what is going on, and then we verify that what is going on actually is going on. So let's say that we ask the platform to do and generate this data set. The first thing that it does is it tells you what it is trying to do first. And by doing that, we ourselves as human beings and who do this type of research all the time, we can think about whether it makes sense and whether it's confirming what our approach is supposed to be. And so here you can see that it is saying exactly what I wanted it to do. It's parroting back to me what I wanted it to achieve. And while it goes along and does these things, it actually shows you the work of what is being done. So let's take an example. So here it's going to start by actually generating those timestamps and trying to generate some information. Here we go. One thing is, again, we always like to look at these things as researchers and make sure that what we wanted is what happened. You can see here, for example, that's not what we wanted. It's close, but it's not exactly what we wanted. And we can, in the same way that we instruct our students sometimes when they bring us things back like this that aren't exactly what were necessary, we just instruct it to do and amend its outputs. So the nice thing about this, again, is that you see all of the outputs. So now it's trying to say, all right, well, I've generated these random things. Here are some transcriptions, right? So you remember how we said at the beginning, man, it would be so nice if we could get actual like real, like something that is more reasonable from these transcriptions, not just random text. Well, that's what's great about having something assistant-like that has knowledge or has been trained on text. And it's that we get these responses that are actually reasonable. So we asked it to have a conversation to simulate this classroom audio conversation. And here we have, good morning, class. Today we're going to learn about ancient civilizations. That absolutely sounds like something that you would hear in a class. And this also, if you read a bit of it, it sounds like the side of a conversation or an instructional period where the teacher would be speaking. So in here, you're not really seeing the student conversation or the student responses, which is what we wanted. But also we see things that we might expect to see in teacher statements. So here you do see a name. We're feeling super excited about life right now because we know that this is a synthetic name and we don't have to have the heart attack that we want to have because it's some student that was actually in the class. And so again, you see some really great conversation on the teacher side. And this is just generated by Code Interpreter based on the fact that I was telling it that this is for elementary school students and it should be a conversation like this. So this is looking great. It's also generating my labels. And what's interesting about this is that I have described to it what the labels are. So for example, an opportunity to respond would be something like asking a question or waiting for a response or something like that. A praise would be like, oh my gosh, Sarah, you've done a great job. And so something that's nice is actually the model will be looking at these sentences and trying to apply the right label to the sentence. Now, sometimes does it do a great job? That is something that we have to see. So here, again, you see the actual code of what the model has generated. That sounds like a reproducible moment. So if we wanted to, literally as we're going along, we could just copy and paste these things. We have, sorry, I'm doing a lot of scrolling. We can just directly copy the code if we wanted to, and that would be something that we can experiment with as we go along while we're working. But there are of course, other ways that we can interact with this. So this is something that's very interesting. So as Jesse was saying before, this is an interactive sort of platform, and it's a self-correcting kind of platform. So right here, you saw that it wrote all of that code, trying so hard to help us make this synthetic data set. And here you see an example of what it does whenever it's trying to make sure that it's doing the correct thing. So here it's executing the code that it wrote in the Python interpreter. And similarly to how we run into code as people who code, we get these errors where it's telling us, oh my gosh, there's this error and like we have to fix it. So now we're actually to the side of this notion of copying and pasting. If we would have copied and pasted this thing just to begin with, we too would have run into the same error. And then we would have had to come back and then like interact. But on its own, with no intervention, so you see no intervention right here for me, on its own, it's trying its best to correct the situation with the wrong links. So here it finally made it to this point, trying over and over again to correct the code that it had to generate the CSV, and beautifully we're able to download those CSVs. However, we did talk about the fact that I was just not liking the format of that timestamp. Whenever I go to use this data and try to do my analyses, it's not going to match the actual data that I'm going to get from the transcriber. So here I needed to fix that. It again runs into some challenges, but it fixes them. Also, we always have NA. If you have a data set that you're creating and it has no NA in it, either you have like a really great like scientific piece of computing or hardware that generates no NAs, or you probably need to add some NAs in there. And so here I added some NAs in this just to represent the data that we would expect. And then also I asked it to really look at those labels, okay, because it doesn't really make sense that some of the statements that I was making should be labeled. It should be more neutral. It's not really a praise, not an opportunity, it's nothing. So then that's what it should do. And so here you also see it doing that. So here you can see that I just go along and I have it generate more data sets. We have this person being happy. One day they're grumpy. You would expect them to have more negative interactions on their grumpy day. And here we go along. And this is precisely what it generates in the end. Again, at the very end, it generates the data set. And then often you have to go through a few steps, just make sure that things are exactly what you want. Here, sometimes, again, as researchers, we can help it more than maybe someone who is not understanding anything about data analysis can help it. And what we can do is we can tell it things that essentially help us while we're coding, right? So sometimes whenever you're getting errors that are like, oh, this doesn't have the right number of rows, this doesn't have the right number of columns, we literally do this. We look at the length of things and every single little thing until we have figured out what it is. And so we can tell it, give it that suggestion, like you're having this issue with the code, just like we would tell our students, look at the length of it. And then after doing this, it takes the advice and then it actually does a little bit better as we go along. And so it's able to actually resolve that issue. Now towards the end, sorry, I'm doing a lot of scrolling. I always try to be nice to it. I always tell it it's my friend, thanks. At the end, we are able to download the CSVs here. And also something that's nice about this is that we can also actually download the code that is required to generate all of this. So normally I would download all of that code like we can see here. But in this particular case, with all of the challenges that it had with the length, I just decided not to do that.
Could we see what the data looks like after you've generated it all?
Yes, 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 yes. Let me pull it up. So, yes, 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 yes. Pull it up. And here we can see an example. Oop, and it should be coming up now. Oop. Sorry, I'm going to share a different screen right quick. And here we can see what we want. So this is actually, I think this one might be an English one. I generated a bunch of these data sets. And it was really helpful. This is actually, this column over here is actually nearly exactly what our data actually looks like. When the people are transcribing, they don't actually transcribe the beginning and ending of every single sentence. Sometimes they just do it at these random intervals that, I mean, it seems like a random interval. So we just simulated that ourselves. And we also have the statements that are unlabeled, which is appropriate because not everything is going to fall into the categories that we want. All right, one more example. Yep.
And so is the idea here then that, so you've generated your sample data. So now you could actually do all your analysis on the synthetic data, but then download all the code and then run it locally when you're secure, you know, locally on your own machine, get all the same graphs and everything, but on the real data. So you never expose your sensitive data outside.
Absolutely, that's exactly right. And so I can give an example of that as well. So one, there is something to see about this now that we're kind of starting at the end. So one, I did an analysis on this data, the synthetic data that was generated. Again, as Jesse said, once we have our synthetic data set, we can then allow Code Interpreter to work on that data set with us. We can do the analysis with Code Interpreter without having to write all that code from scratch. And something, again, nice about that is once we are done with all that analysis and we're feeling pretty confident about what happened, we can download that actually as a Jupyter notebook. And if you work with Python and you work particularly in the areas of data science where we love this literate programming, Jupyter notebooks are going to be a really, really familiar format to you. So they allow you to insert images, have the actual code, and then run it all from top to bottom. So in looking at this, we would see the actual Jupyter notebook with all the information that was in this, real responses, spam responses. Again, this is a simulation of a survey data set. And the analysis that we could do on the simulation data set instead of having to upload the actual data. And again, because our simulation data set, we told it how it needs to exactly match the format of our actual data. Whenever we want to actually do this analysis locally on our own data, we can just put in our own data and then repeat actually the exact analysis and extend it as we see appropriate for our own data. You see? So this was essentially the main part of what I wanted to show you here, that you can download things in a particular format. And again, this is a Jupyter Notebook format. It's a little bit of a non-trivial format in the sense that it's not just like text file, write it straight out. This is like a JSON format with different types of cells. So it's a little bit complex, and the fact that it can generate this and it's then openable is actually really helpful. So here, I'm not going to try to make you seasick. This is, again, an example of how we are creating surveys. Something that usually helps is if you try to put a little context around what you're trying to do, so you can get the general results in the right area. And then you essentially just describe what you're after. So if you just really want to start from scratchity scratch, and maybe you even want it to help you generate the survey, then this is a great way also to help you just begin with the truly foundational things of what's pretty much in every survey. So age, demographic, gender identity, sometimes where you're from, all those kinds of things. Also, as Jesse was saying, these things can help you to think about new questions that you might not have originally thought of to put in your surveys, or ask different kinds of questions or in a different way than you might have originally hoped. Or you can also take the survey, put it into something like Code Interpreter, and then ask it if there's any areas that are missing, or get its insights on what else you could do, or the coverage of your survey. All right, I think that is about it for me. Any questions about generating synthetic data sets, ways to go about it, best practices, tips, anything? All right, fantastic. Thank you very much.
So, in summary, you've seen how you can use large language models from everything from the very genesis of an idea, where you're exploring, maybe covering a lot of ground with different papers, comparing different papers, exploring ideas, through even before you collect your first data point, maybe generating data so you can figure out, and maybe in parallel to collecting the data, actually be working on preparing code to analyze this, or using ADA, advanced data analytics, to help you come up with good visualizations and good explorations. Even if you have sensitive data, first generating the synthetic data, so then you can bring that local and then run all of that locally as well. All the way to finally getting the final graph that you want, and actually iterating on that until you get it exactly the way that you want it. Gregor.
Do you know what is the limit on the data that you can upload? So we have, for example, these time-lapse data set, and they are kind of complex. They have like biological replica under the same condition, and then many different conditions. And what I would love to do is to basically feed the data in and then ask what are common features in the data that you could extract, and then also taking into account the replica data that we have, so that you basically don't over parameterize the features. And it's really important to actually look at this data set in a comprehensive manner. I mean, I could start with basically looking at replica experiments and then ask, okay, what are common features among these 3 data sets, and then do this for each of the condition, and then go from there and then see what is similar and what is different. But do you know if there's a limit about how much you can upload?
Yeah, so in this case, when you're using ADA, that we were just looking at, it's a pretty limited compute environment. There is an open source version of this called Open Interpreter. We'll be starting to look at that. But one possible approach is that you go ahead and explore all the questions, but with a sample of the data, knowing that you're not getting the full answer, right? But then you do that, the visualizations you want, the different types of analysis you want, then again, bring it local, and then run it on a much beefier instance. So then you can run all of the data, because you'll have a much better compute environment locally than you can with Code Interpreter ADA. But another approach is maybe using Open Interpreter if you really want to be doing this exploration aided by the AI and have this immense compute. So that's another possibility, and we'd be happy to talk to you about what that might look like. But just in a quick shorthand, that would be using a model. You might be able to use GPT-4, but you'd have to use it through what's called an API, and then you'd have to be running your open interpreter locally. But a couple of different ways to possibly do that. But with the sort of the straight out of the box OpenAI ADA, it's pretty limited compute. It's better than the context window, but it's going to be maybe we've not explored to see what the limit is, but it looks to be on the order of a couple of megabytes, maybe a little bit north of there. Probably less than a gig though. And those ways around it. Great question. Other questions or comments? All right. Then I would like to invite you all to our AI Friday. We have it every Friday from 10 to 12, where you can drop in with questions, ideas, if you want to talk more in depth about these things and explore what possibilities are. Like if you're intrigued by the idea of the open interpreter, come on by, talk to us about it. We'd love to have you. As a matter of fact, this Friday, we're going to be having a one-day late celebration of the Mid-Autumn Festival. So celebrate a number of different Asian cultures, but we will have moon cakes. So if you are away from home and you want to be able to celebrate Mid-Autumn Festival, you can come by and have some mooncakes with us and talk about AI. 10 to 12 at 19th and Grand. But otherwise, until our next workshop, thank you all for being here, and thanks for your great questions.
Thank you very much for putting this together.
Absolutely. Thank you, Katie. Thank you, Ryan. Thank you, Sarah. Thank you, Juan. Excellent. I will go ahead and shut down the meeting now.